Okay, so in this video, we are going to discuss October-November paper 2022, paper 6-2. Okay, so let's start with question number 1. It is given that we have a random sample of 80 adults, and then we are having the estimate of the heights. Okay, so for the adults, which is in h meters, and these are the results that we have, where n equals to 80, summation of h equals to 2048, and also summation of h squared equals to 52760. So they want us to find the unbiased estimates of the population mean and also the variance. So the keyword for this question will be unbiased estimates. And for the estimation for population mean and variance, right, basically there are two formulas here. If you refer to the formula booklet, it is provided under the part of probability and statistics. So if you have a look, this is what we have, unbiased estimator. So the unbiased estimator, to get the value for mean, it will be summation of x divided by n, and this is the formula for unbiased estimated variance. Right, so I'll bring it here. Okay, so the formula for mean will be summation of x divided by n, where the formula for the unbiased estimated variance will be 1 over n minus 1, and then summation of x squared minus summation of x, the whole thing square, divided by n. So this is a general formula for unbiased estimates for population mean and also the variance. And now we are going to apply and substitute all the values that we have here. Okay, therefore to get the unbiased estimated mean, it is quite straightforward, where we are taking the summation of h1 in our example here, which is 2048, divided by the number of sample, which is 80. So if we try to simplify this part, we will get 25.6. Right? And for the unbiased estimated variance, okay, so according to the formula, we have 1 over n minus 1. So we are having 1 over 79. And summation of x squared, we will want to substitute the summation of h squared, 52760, minus the summation x squared. That means we substitute this one, 2048 squared, and then divided by the n, which is 80. Okay, so again, by pressing calculator to help us, we will have the answer. If it is in the fraction form, that will be 1656 over 395. Okay, or you can change it, become 3 significant figure answer, where it should be 4.19. Right, so this is how we answer part A. Let's proceed to part number B. So for part number B, they are saying that using this sample, we have the upper boundary of the alpha confidence interval for the population mean is 26.0, and they want us to find the value of alpha. So for this question, basically we are talking about the confidence interval. Okay, confidence interval for the population mean, and then we are having upper boundary, which is 26. For the formula of the confidence interval, right, for the population mean, the limit formula will be summation, the sample mean plus minus z multiplied with sigma over square root n. So this is a general formula for the limit of the confidence interval. And since they are talking about upper boundary, so upper boundary, that means we are having the summation, the sample mean plus z sigma over square root n equals to 26. Alright, so upper boundary equals to 26, and therefore our upper boundary is x. Upper boundary means the larger value, right? So you will have sample mean plus z multiplied with sigma over square root n, and it is equals to 26. Okay, so we have to substitute all the value that we already get just now. The sample mean is actually our unbiased estimated mean as well. We are having the same value for these two, right? So we are having 25.6 for the sample mean. The value of z, I don't know what is it, so I just put it as z. So for sigma, so to substitute the value of sigma, which is the standard deviation, we will take the unbiased estimated variance and we square root it. Alright. Therefore, when I want to find out the value for standard deviation, I will take square root of 1656 divided by 395. I will keep it as a fraction because I want to substitute it in this second part so that I can get the most accurate answer. Then divided by the n. So what is the n here? It will be 80. And we let it equals to 26. By simplifying this equation, eventually you will get the value of z, and we can see that the value of z is actually 1.747. Okay, so what is the use for this z equals to 1.747? If you want, we can try to sketch the diagram for a normal distribution, and also we try to link it with the confidence interval. Okay, so let's say this is a normal distribution curve, and then we are having the symmetric curve. Assume that we are having the symmetric curve. Okay, when we want to find out the confidence interval, right, basically they are symmetry, okay, with the confidence level in the center. So this is actually my alpha percent, which is my confidence level. Alright, and then these two sides, okay, are the area that we don't want, right? So the z equals to 1.747 actually means this value. So for this value, z is equals to 1.747. And then to get the alpha, the idea is basically we can try to find out this upper area first. Okay, so we can find out this upper area first, and since this curve is symmetrical, right? Therefore, the value for the smaller area here is the same. Since they are symmetrical, so it should be the same. Alright, when we try to find the confidence interval, right? Plus and minus z sigma over square root n, basically they also tells you that they are symmetrical, right? So this value is negative 1.747. Okay, but we are not interested in that. For me, I will want to find out the greater area here. So for me, I will try to find out the area where z is greater than 1.747. Okay, so to get the value z greater than 1.747, I need to take 1 minus z smaller than 1.747. So I go to the normal distribution graph, the table, look for the value of z 1.74, where I got this one, and then 7. So the same row is value 6. So I have to take 9591 plus 6 at the last digit. 9591 plus 6 at the last digit, and I will get the value 1 minus 0.9597. And the upper area, shaded area here that I get is actually 0.0403. Alright, okay, so once I know the upper area is 0.0403, so to get the alpha, according to the curve that we have here, the distribution graph that we have here, to get the alpha percent, what we need to do is like I have to take the total area under the graph, which is 1, minus 2 times of the upper area. 2 times because of the lower area here is also having the same area, okay, same value, right? So I'm having 1 minus 2 times of 0.0403. When I take 1 minus these two areas here, I'll get the area in the center. And if we want to change it become percentage, therefore we will multiply it with 100%. Okay? And when we try to simplify this value, you will get 91.94%. And our final answer can be 91.9%, correct to 3 significant figures. Or if you use this value, which is not in a fraction, and the sigma which is not in a fraction, you might get 92%. Alright, so both answer 91.9 and 92% are accepted in the marking scheme. Okay, so this is how we decide the value for the alpha. Okay, so now we come to question number 2. In the past, the mean length of the particular variety of worms has been 10.3 cm with a standard deviation of 2.6. So following a change in the climate, it is thought that the mean length of this variety of worm has decreased. So highlight the word decrease. this is the word or the keyword help us to form the alternative hypothesis. All right, the length of a random sample of 100 worms in this variety are found, and the mean of this sample will be 9.8. So for your information, right, this mean for the 9.8, it is actually from the sample of 100 worms. Therefore, the 9.8 here will be the sample mean, and this one should be the population mean, the 10.3. Okay, so assuming that the standard deviation remains the same, carry out a test at 2% significance level whether the mean length has decreased. So again, you can see the keyword decrease here. Okay, so this is the keyword help us to form the alternative hypothesis. Right, so they are talking about the mean, okay, the population mean, and we want to see whether the population mean has been decreased or not. And you can see that our sample size here is 100. So basically, we are going to use the normal distribution, okay, that involves the sample mean with large sample. So let us start the test. Okay, so first step, we need to form the null and alternative hypothesis. Because of the word decrease, okay, decrease, therefore I know that my alternative hypothesis should having the population mean, which is smaller, decrease means smaller, right, than the original mean, which is 10.3 cm. And for our null hypothesis, it will be equals to 10.3 cm. So this is our first step. And second step, we need to decide what is the distribution. Since we're having a large sample, right, large sample size, and therefore the sample mean will be approximately normal distributed. Okay, so what is the mean that we are using here? It will be the population mean, which is 10.3, and the variance should be population variance, which is 2.6 square divided by 100. All right, and now I want to calculate and get the value for test statistic. Okay, so if I want to get the value for test statistic, okay, so the formula should be Z equals to, so we are using the sample mean formula, right? Okay, so we are having sample mean minus the population mean divided by standard deviation over square root n. So if I try to substitute the value here, our sample mean value will be 9.8, which is given in the question. So we are having 9.8 minus the population mean 10.3 divided by standard deviation. We are having 2.6 over square root n, which is square root 100. Okay, so from here, I will get the test statistic, which is negative 1.923. Alright, so after the test statistics, I will want to find out the critical value. Okay, so to get the critical value, I will label it as ZC. To get the critical value, if you try to observe the null and alternative hypothesis, right? Okay, our rejection region should be on the left hand side because of the sign smaller. And then this is the critical value that we want to find. So I think very obvious, this value should be a negative value in our test here. And then the area below this critical value should be 0.02 because the significance level is 2%. Alright, okay, so to find out the critical value for C, instead of using the area 0.02, I will need to look for the area, which is 0.98. So let's have a look for 0.98. So 0.98 will be the probability. So I will want to find out inside from the value inside. I will try to get one value which is very close to 0.98 but lower than it. So this is the value 0.9798. So if I read out the value, it should be 2.05. Okay, and then you need to add a 2 at the last digit. So for the 2 here, you can use either 4 or 5. So if you try to get the value for Z, it will be 2.054 or 2.055. Okay, therefore my critical value should be 2.054 or 2.055. Okay, but from the diagram that we have here, our rejection region is on the left hand side and the value for critical value should be negative value. So you can write as negative 2.054 or you can write as negative 2.055. Alright, and next step, we want to make a decision for our test. Okay, so should we reject or accept the null hypothesis? Basically, we will compare the test statistic and also the critical value. So from here, before I decide it, I realize that the test statistic okay, which is negative 1.923 is actually greater than the critical value, which is negative 2.054. Okay, so I try to erase this one. Alright, so it is greater than negative 2.054. Or if you want to have a look from the diagram, right? This one is negative 2.054, right? And negative 1.923 falls under the acceptance region. Okay, so from here, we know that we should accept the null hypothesis where our conclusion and decision should be do not reject null hypothesis. If we do not reject the null hypothesis, means that there's no evidence to show that the alternative hypothesis is correct. All right, so our conclusion in this context will be there's no enough evidence to show that the mean length of the worm has decreased. Alright, so basically this is how we carry out the test. Okay, so question number 3. So we have 1.6% adults in a certain town ride a bicycle, and there's a 200 adults, a random sample of 200 adults from this town is selected. So they want us to use a suitable approximating distribution. So this is a keyword, suitable approximating distribution, to find the probability that more than 3 of these adults ride a bicycle. Okay, so from here, right, we are having a percentage with a number of large sample. Basically, we should know that original distribution should be binomial distribution. Right, so we are having n, which is 200, and also the p will be 0.016. And since they ask us to use the approximating distribution, right, when we are having a super large sample size with a very small p, the proportion, so we actually can change it become Poisson distribution. All right, so to get the Poisson distribution, to get the mean value lambda, it should be n times p from the binomial, because the mean from binomial is n times p, right? So I take 200 multiply with 0.016, and the mean for, or the lambda for the Poisson distribution is 3.2. Okay, so where this one should be n times p. Okay, then now we want to calculate the probability that more than 3 of these adults ride a bicycle. So the number of adults ride a bicycle should be more than 3. So more than means not included the equal sign. And then we are having a 3 here. For Poisson distribution, we can't find out the probability with x greater than. There will be unlimited, right? So you have to take 1 minus x smaller equals to 3. That means when you want to take 1 minus, the value of 3 should be included. And now you try to put in the value and the value into the formula for Poisson probability. So it will be E negative lambda. So E negative lambda means negative 3.2. Our lambda is 3.2. When x equals to 0, it is always a 1 here. When x equals to 1, it is always the lambda, which is 3.2. When x equals to 2, it will be 3.2 squared divided by 2 factorial. And when x equals to 3, it should be 3.2 power 3 divided by 3 factorial. Okay, then by the help of using calculator, right, we can simplify our answer. This one should be the original answer, and our final answer correct to 3 significant figures should be 0.397. This is the answer correct to 3 significant figure. Okay, and now let's proceed to part number B. for part number B, they want us to justify your approximating distribution, and 2 marks will be given here. Okay, so basically, right, for this approximation, this question, there are some criteria that we need to fulfill, okay, or we need to meet when we want to change one distribution to the other one. So for this distribution, we are changing it from binomial to Poisson. Okay, so when we change binomial to Poisson, the criteria that should fulfill is your n should be greater than 50, which in our question here it fulfills because our sample size is actually 200, which is more than 50. Okay, and the second criteria that we have is NP must be smaller than 5. So if we double check in our calculation just now, our mean, the lambda n times p is actually 3.2, which also fulfill this criteria, NP smaller than 5. So these two are the reason that allows us to change the binomial become Poisson. So originally it is binomial distribution with the n and p, okay, and we are going to change it become the Poisson distribution where the lambda is equals to n times p. So this is all the criteria that we need to meet before we can change binomial become Poisson. Okay, so now we are now at question number 4. We have the number of faults in growth made on a certain machine has a Poisson distribution, so the keyword is Poisson, and then with the mean 2.4 per 10 meter square. So the adjustment is made to the machine and it is required to test at a 5% significance level whether the mean number of faults has decreased. Okay, so highlight the word decrease, it will be the keyword to help us form the alternative hypothesis. Alright, and then we are having a randomly selected 30 meter square of growth is checked and also the number of faults is found. So first question, they want us to find the suitable null and alternative hypothesis for the test. Okay, so to form the null and alternative hypothesis in Poisson distribution, there are two values of mean that you can use here. You can use the mean given originally, which is 2.4 for 10 meter square, or you can use the mean for the 30 meter square, where we are using it to find out our to run our test later. All right. So you can write out both. You can write either 2.4 or you can write out 2.4 times 3 for 30 meter square. Alright, so the keyword here is actually decrease, right? So the word decrease helps me form the alternative hypothesis where it should be lambda. Decrease means smaller than, I'm using the lambda for 30 meters square. So I will take 2.4 multiply with 3. Okay, 2.4 is for 10 meters square. So for 30 meters square should be 2.4 multiplied with 3. So if I have 2.4 multiplied with 3, it will be 7.2. So there will be 7.2 faults for 30 meters square. Okay, so if you want to use 2.4 also can, which is for 10 meters square, no problem. Right, so for our alternative hypothesis, it will be smaller because of the word decrease. And then for the null hypothesis, we will always write equal sign to 7.2. Okay, so this will be our null and also the alternative hypothesis. Then next, they want us to find the probability of a type 1 error. Okay, to get the type 1 error, the definition for type 1 error will be actually we reject the null hypothesis when the null hypothesis is true. This is the first type of error, right? Okay, to calculate the probability under this part, the reject null hypothesis part, I need to find out rejection region first. Okay, I need the rejection region before I can continue to calculate the probability. For the rejection region, I need to find out the value of x one by one. Okay, so since I know that it is Poisson distributed and the lambda is 7.2, okay, and I want to find out the area which is smaller, that means on the left hand side. Alright, so on the left hand side, basically we should have x. By right, we should start from x smaller equals to 0, then followed by x smaller equals to 1, then x smaller equals to 2, and so on. Okay, so I know that x smaller equals to 0 and x smaller than equals to 1, right? It should be they should be quite sure that they are in the rejection region. Okay, but no matter how, I will still start from x smaller equals to 1. So to get the probability for x smaller equals to 1, I'm having e negative lambda. Okay, then x equals to 0 means 1, x equals to 1 means lambda. Okay, so when I calculate this probability, I'll get 0.00612, and you realize that this value is actually smaller than the significance level, which is 5%, or we write as 0.05. That means x equals to 1, right? It is still fall under the rejection region, and now we can have x smaller equals to 2. So for x smaller equals to 2, I will take e negative lambda. X equals to 0 is a 1, x equals to 1 is lambda, x equals to 2 will be lambda square over 2 factorial. For this particular probability, the value that I get is 0.0255, where we realize that it is still smaller than 0.05. Okay, and then let us continue for the next value, where I want to find out the area for x smaller equals to 3. So I'm having e negative 7.2, and then the formula for the probability that includes until x equals to 3 will be something like this. Okay, so if I try to use calculator to help me, I'll get 0.0719. And if you try to compare this value with the significance level, right, it is already more than the significance level, which is more than 0.05. Okay, so from here I think we should stop, because we already know where is the rejection region, right? So from here you will see that x equals to 1 is under the rejection region, x equals to 2 is also under the rejection region, but x equals to 3, okay, for the area that is smaller than x equals to 3, it already more than the significance level. Therefore, x equals to 3 already falls under the acceptance region. Alright, so from here we know that the rejection region is x smaller equals to 2. Or the critical region, I will call it as critical region, so it will be equals to x smaller equals to 2. And for this question, they're asking us to calculate the type 1 error. So the probability of type 1 error, it will be x smaller equals to 2 when the lambda is equals to 7.2, right? So if you try to observe, basically we already get the probability of x smaller equals to 2 just now, which is 0.0255. Alright, so we can straight away write out the type 1 error, which is equals to 0.0255 here. Okay, so this is how we calculate the type 1 error. So before that, we need to find out the rejection region first. For this question, the rejection region is not provided, therefore you have to test it one by one, right? Then let's proceed to part number C. Okay, so for part C, they are saying that exactly 3 faults are found in the randomly selected 30 meter square of growth, and then they want us to carry out the test at the 5% significance level. So at 5% significance level, right, we know that our rejection region is actually at x smaller equals to 2. And then you realize that x equals to 3 already outside the rejection region. Okay, so x equals to 3 lies outside the rejection region. From here you can see very clearly, right, outside the rejection region. Alright, so therefore from here we can make a conclusion that when x equals to 3 is actually outside the rejection region, means that it is in the acceptance region. So our decision will be to not reject the null hypothesis. And if we do not reject the null hypothesis, it means that there's no enough evidence to show that the fault has decreased. Okay, so there's no enough evidence to show that the mean number of faults has decreased. Okay, so this is how we carry out the test by looking at the value of x and also the rejection region. Alright, then now let's proceed to part number 4. Later, a similar test was carried out at the 5% significance level using another randomly selected 30 meter square of growth. So given that the number of falls actually has Poisson distribution again, then now we are having a new mean. So the mean is 0.5 for 10 meter square. Find the probability of a type 2 error. So again, before we can calculate the probability of type 2 error, right, let's have a look at what is the definition for type 2 error. So for type 2 error, basically means that we accept the null hypothesis when the null hypothesis is false. Okay, our original null hypothesis, right, the lambda is equals to 7.2 or maybe 2.4 per 10 meter squared. But when the null hypothesis is false, right, we need another new lambda, okay, to calculate the probability. So here they are giving us a new lambda. Okay, so this is the new lambda where it is equal to 0.5 for 10 meter square. For the part acceptance region, the accept null hypothesis, we actually do input the acceptance region. Okay, so if I want to translate everything here into the symbol form, acceptance region is x greater than 2, right? Because in the previous part, we know that our rejection region is x smaller equals to 2. And this is a Poisson distribution. Therefore, the acceptance region will be x greater than 2. And then what is the new lambda for 30 meters square of growth? So the lambda will be 0.15. 0.05. If you want to know, it should be 0.5 times 3. 0.5 times 3. Then the lambda should be equals to 1.5. Which means that currently you are having the new Poisson distribution with the lambda 1.5 actually. Okay? And now we want to calculate the probability that x is greater than 2, okay, for this lambda. So for Poisson distribution, I have to take 1 minus x smaller equals to 2. And by using the new lambda and also the formula for Poisson distribution, we will have E negative lambda. When x equals to 0, it is always a 1. When x equals to 1, it is always the lambda. When x equals to 2, it will be lambda square over 2 factorial. Okay, and then of course I use the calculator to help us. We will get our answer 0.191 correct to 3 significant figure. Okay, so this is how we answer question number 4. Okay, so question number 5. X is a random variable with this distribution. So from here, you know that it is binomial distributed, and we have a random sample of 160 values of X is taken. So we are having a large value for sample size now, right? 160 will be the sample size. They want us to find the approximate distribution of the sample mean. Highlight the word sample mean. So this is actually a keyword. So this question basically related to sampling distribution, all right, including the value of the parameter. Alright, so originally we are having binomial distribution for the x, but since the sample size is very large, which is 160, therefore the sample mean for this distribution will be approximately normal. So you can write it as sample mean is approximately normal distributed. Okay, and then they want us to give the value of the parameter. Alright, so to give the value for a parameter for any sampling distribution, okay, so what is the general formula? So the sample mean, basically it is still equals to the population mean, which is summation of x over n. Okay, or any other formula that is sample mean. Okay, so maybe for this one, we are having binomial distributed. We are having binomial distribution at first, right? Therefore, the sample mean will be equals to the population mean, where it is equals to n times p. Okay, and then for the variance for sample mean, okay, so to get the variance for sample mean, or you can write as s squared, right? I think our formula or our notes usually we will write as s squared. Oh, never mind. Sigma square, and then you need to know that this is actually the variance for sample mean. So the variance for sample mean will be the population mean, population variance divided by the sample size. So please tell that the both end here are different. So to differentiate it, right? So I put it as sample size NS, right? Okay, so let us start. The sampling distribution, the mean value of mean should be n times p, where the n is 10, p is 0.2, right? If you take n times 3, you will get a 2. And then for the variance, you should take npq, where it is 10 multiply with 0.2 multiply with 0.8, q is 0.8, and divided by the sample size. So for this question, the sample size is basically 160. So you divide it by 160, and therefore the variance for sample mean will be 0.01. So these are the two values where we call them as parameter. Alright, and you should show them that, you should let them know that it is actually normally distributed. Okay, so let's proceed to part B. For part B, they want us to find the probability that the sample mean, so highlight the keyword sample mean, is less than 1.8. Since we already know the distribution of the sample mean just now, where it is normally distributed with the mean 2 and also the value 0.01, right, for the variance. So if I want to calculate the probability of sample mean, which is less than 1.8, you should change it become Z. Okay, so the value of sample mean minus the mean divided by the standard deviation. So I will divide it by square root 0.01. Okay, then find out the value of Z, which is -2. And to get the area for Z smaller than -2, you have to take 1 minus Z smaller than 2. So again, we go back to our normal distribution table, look for the value of 2 here. So 2.0 is this one, and the value that we get should be 0.9772. So we go back to our part number B. Okay, so I have to take 1 minus 0.9772, and from here I get 0.0228. Okay, so this is how we get the value for the probability. And then for this question, there are some details that you need to know. Some students might ask that originally we are having binomial distribution, right? Okay, where the mean is, the n is 10, and then the p is 0.2. And then when we change it become the sampling distribution, it is normally distributed. And for the binomial, it is actually discrete, and the continuous, and the sample mean is actually normal, which is a continuous random variable. So when we change anything from discrete to continuous random variable, right, by right, we should actually make a continuity correction. And for sampling distribution, right, the continuity correction is 1 over 2n. By right, it should be either plus 1 over 2n or minus 1 over 2n. Okay, but because of we are having a very large value for the n, right? So when you take 1 divided by 2 multiply with 160, we get a very, very small value. Therefore, usually when we are having a super large value for n, right, when we change from discrete to continuous random variable for the sample mean, we actually allowed to ignore the continuity correction. Alright, so for those who still include the continuity correction in your calculation here, basically your answer for this part will be 0.0212. Okay, if you carry out the calculation by using the continuity correction, then your final probability should be 0.0212. So in marking scheme, basically they accept both answer, but mainly for the latest syllabus that we have, we are allowed to ignore the continuity correction because the n is very large and the continuity correction value is very, very small. Alright, so my main answer here it will be 0.0228 without the continuity correction. Okay, so this is how we answer question number 5. Okay, so let's continue with question number 6. Okay, so we are having the masses in grams of small and large bags of flour have the distribution. Both are normally distributed. And then maybe to make the calculation easier, I will let the small bags as S and then the large bag as L. So this is the distribution for S that I have here, like the small bags one, and then this is the large bags that I have. Okay, so Andrea select 4 small bags of flour and 2 large bags of flour at random. So we are having 4 small and also 2 large. First of all, they want us to calculate the probability that the total mass, the keyword is total, the total mass of the 6 bags of the flour is less than 4130. Okay, so the keyword is total. Before we want to find out the probability for this mass, for this random variable, right? You need to know the mean and also the variance for this random variable first. Okay, so to calculate the total means that I'm having 4s plus 2l. Okay, so first of all, I need to calculate the mean for 4s and also 2l. To get the mean, it will be 4 times of mean s, which is 510, plus the mean of 2 times the mean of l. So this is the mean of l. So 2 times is 2 times 1015. And the value of the total, the mean for the total will be 4070. For the variance, okay, so for the variance, by right, the total for the 4s means S1 plus S2 plus S3 plus S4. So to calculate the variance, you also times 4 only without the square. Okay, when it is a multiple in the random variable, then when you want to calculate the variance, only we have the square. So this is total, so total means there's no square. So we are having 4 times of variance of small pack, it will be 100, then plus 2 times of the variance of the large pack, which is 324. Okay, so for the variance of the total 6 bags will be 1048. And from here, we know that 4s plus 2l, because both s and l are originally normal distributed, therefore when we are having 4s plus 2l, the mean will be 4070 and the variance will be 1048. Okay, so now we can start calculating the probability. They are saying that the total of 6 bags will be less than 4130. Since we know that they are normal distributed, so we have to change it become Z by standardizing them. So 4130 minus the mean divided by the standard deviation. So for standard deviation here is actually 1048 square root. Okay, find out the value of Z correct to 3 decimal places. We will have 1.853. And we can directly get the area for this value, Z smaller than 1.853 from the table. So again, look for the normal distribution table, look for 1.853. Okay, so let me clear this up first. 1.8, then 5 is this one, and then 3 is this one. That means you have to take 9678 plus 2. Okay, so 9678 plus 2, and therefore you get 0.9680. So for our final answer will be 0.9680. Okay, so this is how we actually get the solution for this part A. Alright, then let us proceed to part B. Okay, so for part B, they are saying that find the probability the total mass of the 4 small bags is more than the total mass of 2 large bags. So from here, you can see very clearly that they are still talking about the total. So 4 small bags means 4s greater than 2l. But when you want to calculate the probability like 4s greater than 2l, we can't really calculate it. We have to move all the variable to one side first. It means that eventually we will have 4s minus 2l greater than 0. So before we start, we need to find out the mean and also variance for this random variable first, 4s minus 2l. Okay, so let us start. First, we need to find out the mean for 4s minus 2l first. So what is the mean for 4s minus 2l? Again, 4 times of the mean of s, the small bag, which is 510, minus 2 times of the large one, which is 2 times 1015. So from here, you'll get a 10 as the mean. And then for the variance part, again, all the keywords here are still total. It is not a multiple of random variable with the number. Therefore, total means that the 4 of the variance, it is still a 4. We didn't square it. Multiply with the original one, the small bag variance, which is 100. Then for variance, right, although we are having negative in the random variable, but it is always a plus. Variance is impossible for us to get a negative value for variance. So 2 is still a 2. Then multiply with the variance for the large pack, it will be 324. So if I total this out, you will realize that the variance for this question is still the same like part A. Although this one is minus, but the variance are always positive. Therefore, the final variance, it is still the same, which is 1048. And we are having 4s minus 2l, right? Okay, both s and l are normally distributed originally. Therefore, 4s minus 2l also normally distributed. So I'm having 10 is the mean, 1048 is the variance. Okay, and now to calculate the probability, they want us to get the probability for 4s greater than 2l, where we can rewrite it become 4s minus 2l. So this is normally distributed. We have to standardize it become z. So I take 0 minus 10 divided by square root of 1048. Find out the value of z correct to 3 decimal number, 3 decimal places. So I'm having negative 0.309. So this area basically is the same as z smaller than 0.309. Okay, and then we can get the answer from the table 0.309. So you look for 0.30 and then 9. That means you have to take 6179 plus 34 at the last 2 digits. Okay, so you take 6179 plus 34, eventually you should get 0.6213. Alright, so I will want to round off my answer to 3 significant figure where I'm having my final answer at 0.621. And this is how we get the probability. Okay, so now we are at the last question. Okay, the diagram shows the graph that the PDF for the random variable x is taken the value from negative 3 until 2. So you can see from here negative 3 until 2. Okay, so between negative 3 until 2 there are some functions here. Okay, so given that the graph is symmetrical about the line x equals to negative 0.5. Okay, so the symmetrical line is actually x equals to negative 0.5. So that means it will be roughly here. Okay, so this value is negative 0.5. And then they are saying that x smaller than 0 is p. They want us to find the probability of x between negative 1 until 0. Okay? Alright, so this is a continuous random variable. When we want to find out the probability for x smaller equals to x greater than negative 1 but x smaller than 0, basically the area that they want us to find is this one. Okay, so this is the area that they want us to find out. Okay, so to find out this area for the continuity correction, for the continuous random variable question, right? Okay, we can actually take the probability that x is smaller than 0, which is this red color one, minus the green color part. So if I take the red color area for the whole part minus the green color area, then I will get the area that I want, right? So for the red color area, if I write it out, it should be x smaller than 0, which is this whole thing. Okay, and then minus x smaller than negative 1, which is this one. Okay, so this part I can rewrite it become x smaller than negative 1. Okay. Alright, then how should we continue? X smaller equals to 0, I think it's quite straightforward because it is the p. And then for x smaller equals to negative 1, I don't have the value for now. Okay, so I need to maybe further consider how can I make it done, right? So if I try to observe the diagram again, if I take x smaller than 0, which is a p, and if I try to use the value here, this one, because just now we know that the line of symmetrical is x equals to negative 0.5, right? So from here, we actually know that if let's say x smaller than negative 0.5, it should be equals to 0.5 because it is the center of the diagram. Okay, so now if I try to rephrase it again, then maybe I can consider, okay, I know that this whole area is this whole area is 0.5, and then my value for x smaller than 0 is a p, right? So if I take x smaller than 0 minus x negative 0.5 smaller, I will get this area. And then to get the area between -1 until 0, that means I need to have this blue color part and yellow color part, right? And this blue and yellow color part, they are symmetrical. I mean, they are the same because the diagram is symmetrical. Therefore, if I can find out the yellow color part, then I can find out the blue color part as well by equate it. Okay, they are the same area because the line of symmetrical is at -0.5. So I hope that you understand what I said here, right? So maybe I need to change my steps again. Okay, I'm having x smaller than 0 minus the probability of x smaller than -0.5, which is a yellow color area here. Okay, and then I need to times 2 for the whole thing because the total area that I want to find is blue and yellow. Blue is the same as yellow, therefore I straight away times it with 2. Okay, so if I put in the value x smaller than 0, I have a p. X smaller than -0.5, I have 0.5 here. So 2 multiplied with p, I get 2p, and then 2 with 0.5, I get a 1. Therefore, the probability for this area should be 2p minus 1. Okay? And now let's continue to part B. So for part B, they give us the probability density function already. This is the probability density function. And then from -3 until 2, it is defined until -3 until 2. They want us to show this equation. Okay, so we can use the property for the continuous random variable, where if we try to find out the total area under the graph, right, from -3 until 2, we will have the value equals to 1. Okay, so the function that we have here is -ab x squared plus x dx. If we integrate the whole area, to find the area, we need to integrate it. Alright, so to find the area under the graph, we integrate it from -3 until 2, and the total area under the graph, I know that is equals to 1 for continuous random variable. So I will start the integration now. Okay, so integrate a, I got ax. Integrate bx squared, I'm having bx power 3 divided by 3. Integrate bx, I'm having bx squared divided by 2. And then I need to substitute in the value for 2 and also the 3. 2 and -3, sorry. Okay, so if I substitute 2 inside the equation here, then I will have 2a minus 8 over 3b, then minus 2b. And now I want to substitute -3. If I substitute -3, I'm having -3a, then plus 9b minus 9 over 2b. Okay, if I try to further simplify everything here, I will have 5a minus 55 over 6b, and it is equals to 1. And we try to make the denominator disappear, multiply the whole equation by 6. So I'm having 30a minus 55b equals to 6. So I think this is how we get the equation that they want us to show. Okay, and now let's proceed to the next part. For the next part, they are saying that by substituting a suitable value into the fx, x into fx, find another equation relating a and b, and also determine the values of a and b. Alright, so we need another equation so that we can solve simultaneous equation with this part 1 just now. Okay, so this is the first equation. We need a second equation to solve for the value a and b. So which is the value that I should substitute? So to make the calculation easier, you can try to consider substitute 2 into the function f, or substitute -3 into the function f, so that you can get they are equals to 0, right? Okay, so I will substitute value x equals to 2. Okay, so I'm having my first equation. First equation is 30a minus 55b equals to 6. This is my first equation in the previous part. Okay, so now I want to substitute 2 into the function f, and I will get a 0. From the diagram, you can see that substitute 2, you'll get a 0 for the y, right? So f2 equals to 0. When you substitute f equals to 2, you will have a minus 6b equals to 0. Substitute into the function just now. The function is this one, right? Okay, so if you substitute into the function, you get a minus 6b equals to 0, where you get a equals to 6b. And this is your second equation. Again, to find out the a and b, you just need to solve these two equations simultaneously. So I'm having 36b minus 55b equals to 6. Simplify this equation, I'll have the value of b, which is 6 over 125. Okay, so this is my answer for the b. And if I continue to substitute the b into a, then I will have 36 over 125 for my a. And this is how we get the value for a and b by solving the simultaneous equation. Okay, so here we finish discuss all the question for this paper, and thank you very much for watching this video.